Welcome to our Class 10 Science Learning Series. In this video, we will study NCERT Science Class 10, which is the official book recommended by CBSE for board examinations. This book explains scientific concepts in a simple and practical way with activities, examples, and experiments. It helps students understand science clearly and prepare well for exams. In this series, we will cover each chapter step by step, making the concepts easy to understand. Table of contents. Students, before we start, let's quickly look at the chapters included in this book. Now students, let us begin with chapter 2, Acids, Bases and Salts. This is a very important chapter because it is not only useful for your board exam but also helps you understand many things that we see in daily life. For example, why lemon tastes sour, why soap feels slippery, why toothpaste is used, why antacids are taken, and how chemicals like bleaching powder, baking soda, washing soda, and plaster of Paris are prepared and used. So, students, in this video, we will cover the chapter in a very simple and easy method. Let us begin. Students, in our daily life, we come across many substances around us. For example, lemon juice, vinegar, curd, tamarind, baking soda, soap solution, toothpaste, and lime water. Now, if you observe carefully, some of these substances have a sour taste, while some are bitter and feel soapy to touch. The sour substances are generally called acids, and the bitter or soapy substances are generally called bases. But in chemistry, we do not define acids and bases only by taste because tasting chemicals is unsafe. So, we define them scientifically. An acid is a substance that furnishes hydrogen ions, that is H plus ions, in aqueous solution. A base is a substance that furnishes hydroxide ions, that is OH negative ions, in aqueous solution. This means when acids dissolve in water, they produce H plus ions, and when bases dissolve in water, they produce OH negative ions. For example, hydrochloric acid in water gives H plus ions, sodium hydroxide in water gives OH negative ions. Students, one very important point to remember is that acids and bases show their properties only in aqueous solution. That means in the presence of water. Without water, acids do not release H plus ions properly and bases do not show OH negative ions properly. So, this is the basic idea. Acid H plus ions, base OH negative ions. Identification of acids and bases using indicators. Now students, the next question is, how do we identify whether a substance is acidic or basic? For this, we use indicators. An indicator is a substance that changes its color in acidic and basic media. This color change helps us identify whether a solution is acid or base. Let us understand the common indicators. Litmus. Litmus is a natural indicator. In an acidic solution, blue litmus turns red. In a basic solution, red litmus turns blue. This is one of the most common tests. Phenolphthalein. In an acid, phenolphthalein remains colorless. In a base, it becomes pink. Methyl orange. In an acid, methyl orange becomes red. In a base, it becomes yellow. Students, these indicators are very important because many exam questions are directly asked from them. Now let us also talk about olfactory indicators. These are substances whose smell change in acidic or basic solutions. Examples include onion, clove oil, and vanilla essence. So, indicators help us identify acids and bases safely and easily. Chemical properties of acids. Now students, let us understand the chemical properties of acids. Acid react with metals. When an acid reacts with a metal, it forms salt and hydrogen gas. For example, zinc plus 2HCl gives ZnCl2 plus H2. Here, zinc reacts with hydrochloric acid and forms zinc chloride and hydrogen gas. This is why bubbles of gas are seen in some acid-metal reactions. Acid react with metal carbonates and metal hydrogen carbonates. When acids react with carbonates or hydrogen carbonates, they produce salt, water, carbon dioxide gas. For example, Na2CO3 plus 2HCl gives 2NaCl plus H2O plus CO2. This reaction is very important. Acids react with bases. When acids react with bases, they form salt and water. This is called a neutralization reaction. Acids in water conduct electricity. Students, acids conduct electricity in aqueous solution because they produce ions. This is another proof that acids release ions in water. Chemical properties of bases. Now, let us understand the chemical properties of bases. Bases are substances that release OH negative ions in water. Bases react with acids. Bases react with acids to form salt and water. Example, NaOH plus HCl gives NaCl plus H2O. Bases in water are called alkalis. Not all bases dissolve in water, but the ones that do are called alkalis. Examples, sodium hydroxide, potassium hydroxide. These are strong bases and are commonly used in industries. Bases feel bitter and soapy. Though we never test chemicals by tasting them, theoretically bases are known to be bitter in taste and soapy to touch. Soap solution is a good daily life example of a basic substance. Neutralization reaction. Now students, let us study one of the most important concepts of this chapter, neutralization. A neutralization reaction is a reaction in which an acid reacts with a base to form salt and water. pH scale. The pH scale is used to measure how acidic or basic a solution is. The pH scale ranges from 0 to 14. If pH is less than 7, the solution is acidic. If pH is equal to 7, the solution is neutral. If pH is more than 7, the solution is basic. Importance of pH in everyday life. pH in our digestive system. Our stomach produces hydrochloric acid. This acid helps in digestion. But if too much acid is produced, it causes acidity and pain. To control this, antacids are used. pH in tooth decay. When we eat sugary food, bacteria in the mouth produce acids. If the pH in the mouth goes below 5.5, tooth decay can begin. Toothpaste is usually basic, so it helps neutralize the acid. pH in self-defense by animals and plants. A bee sting leaves an acid in the skin. This can be relieved by using a mild base like baking soda. pH of soil. Plants grow well only when soil has suitable pH. If soil is too acidic or too basic, crops do not grow properly. Farmers sometimes add substances like lime to improve soil pH. pH of water for aquatic life. Aquatic animals can survive only in water with proper pH. If pH changes too much, it harms aquatic life. So students, pH is not only a chemistry topic, it is connected to health, agriculture and environment. Common salts and important chemicals. Sodium hydroxide. Students, sodium hydroxide is a very important base. Its chemical formula is NaOH. Preparation. It is prepared by electrolysis of brine, which is an aqueous solution of sodium chloride. During electrolysis of brine, sodium hydroxide is formed, chlorine gas is produced, hydrogen gas is also produced. Uses of sodium hydroxide. Used in making soaps and detergents, used in making paper, used in the manufacture of artificial fibers, used for degreasing metals. Sodium hydroxide is also called caustic soda. Bleaching powder. Bleaching powder is prepared by passing chlorine gas over dry slaked lime. Uses of bleaching powder. Used for bleaching cotton and linen in the textile industry, used for bleaching wood pulp in paper factories, used for disinfecting drinking water, used as an oxidizing agent. Bleaching powder is very important in sanitation and public health. Baking soda. Its chemical formula is NaHCO3. Its chemical name is sodium hydrogen carbonate. Uses of baking soda. Used in baking powder to make cakes and bread soft and fluffy. Used as an ingredient in antacids. Used in soda acid fire extinguishers. When baking soda is heated, it produces carbon dioxide gas, which makes bakery products rise. That is why baking soda is so useful in cooking. Washing soda. Its chemical formula is Na2CO3.10H2O. Its chemical name is sodium carbonate decahydrate. Uses of washing soda. Used as a cleaning agent. Used for removing permanent hardness of water. Used in the manufacture of glass, soap and paper. Used in many industries. Plaster of Paris. Now, let us understand plaster of Paris, also called POP. Plaster of Paris is prepared by heating gypsum. Uses of plaster of Paris. Used for making statues, toys and decorative materials. Used by doctors for making plasters for fractured bones. Now, we are covering NCERT in text questions. Make sure you try each question along with me. Pause the video wherever needed and think before checking the answer so that your concepts become strong. Now, we are covering NCERT solved exercise. We will solve each question step by step with proper explanation so that you understand the correct method of answering in board exams and avoid common mistakes. Now we are covering previous year questions. These questions are very important and frequently asked, so focus carefully, practice them seriously and try to solve them on your own before looking at the solution. Practice all these questions regularly to master this chapter. Revision and practice will help you improve your speed, accuracy and confidence for the exam.